Okay, good morning, all of you.
Students, please note down the necessary steps and points. Okay?
Okay, in this session today I will. Sorry, so this is already covered. Okay, today I will discuss the objective of this program is design a step down chopper with R and RL load, design of step up chopper with R and RL load, and design of single phase inverter with R and RL load. So next first step is design of step down chopper with R and RL load. First, this is DC source, BS is DC source. This is switch. Switch in power electronics, any semiconductor switch. It may be any semiconductor switch. It depend upon our application. But in case of DC to DC converter, the MOSFET is the most suitable semiconductor device for low and medium applications. For higher power applications, thyristor is also used. And this is freewheeling diode. And this is output voltage. And this is L operate as a filter. And this is load. So in case of step down chopper, we have required the DC source, semiconductor switch. We can take MOSFET, diode, and this is output voltage. This is inductor as a filter and load. Next, step up chopper, DC source, inductor L, this is switch means MOSFET switch, and diode and load. Next, design of single phase inverter with R and RL load. It consists of 4 thyristors T1, T2, T3, T4, or you can use IGBT also. Okay, any semiconductor switch you can use. It depend upon our application. Low and medium power application, MOSFET or IGBT are used. In generally inverters, IGBT is most suitable. And for higher power application or industrial application, thyristor is also used. Okay, so don't go come back to practical session. Open the MATLAB. New Simulink model. Taking some time. Okay. This window is open. First, assign the name. This is step step down chopper and save. First step, click to the library browser. This library browser. Again, come to the left hand side, click SimCap, and again next step is click to the Sim Power System. Sim Power Systems, and again coming to the subsections Power Electronics. The first we have required MOSFET switch. This MOSFET switch, add to this, or you can drag MOSFET, and diode is also required, add to the step down chopper, and again measurements, measurement of output voltage, this is also add, elements, elements in power electronics always take series or parallel branch, don't take load. In power system we take load, in power electronics take series RLC branch as a load. Next step is electrical source. Electrical source require the DC voltage source. Again come back this point, this DC source, this is MOSFET, the DC source connected in series with MOSFET, and this diode is control R for rotations. And next step is, and this for diode R, this is load, control R, first take resistive load, load resistance is 100 ohm. Okay, filter. Next step is this IGBT, sorry MOSFET. MOSFET require the gate pulse. The gate pulse, again click to the source, take the pulse generators, sync and scope. This sim power system pulse generator is also connected to the gate pulse. This is pulse generators. Okay, then measurement of output voltage input voltage, this is input voltage measurement portion. This is voltage across the load. And again, this is without filter. L is operate, inductor is here operate as a filter. And again, scope always, this history always uncheck. Otherwise, it save only 5000 dot points. You will not get proper output. We have required the 4 sections. The first point is the input voltage. First tab is connected to the input voltage. Second tab is connected to the output voltage without filter. Third tab is connected to the output voltage with filter. And next is last point, fourth point is connected to the pulse generator. This is connected to the pulse generator. Okay. And last point is click to the sim power system. And this is power GUI blocks. Without this block, your Simulink model cannot be run. Okay. Your circuit diagram is completed. Next step is assign the value as per your desired. If you are taking the input voltage as 100 volt, or you can take any value 50 volt, 100 volt. For example, you are taking 50 volt. And this is pulse generators. Pulse generator means this is control section. The control section voltage is generally from 1 volt to 10 volt. And default is magnitude is 1. And this is time period. Time period for the MOSFET switching frequency is 100 kilohertz, 200 kilohertz or 500 kilohertz. For example, we are taking the 100 kilohertz. 100 kilohertz means in time 1 into e की power minus 5 means time is equal to 1 upon f. 1 upon f means 1 upon 100 kilohertz. तो टाइम में क्या हो जाएगा 1 into 10 की पावर minus 5. e की पावर minus 5 is means 10 की power minus 5. And pulse width means due to ratio you are taking the pulse width is 90%. Means the time duration 90% time is on and 10% is time only for off. And in case of DC, the phase delay is always 0. No phase delay in case of DC. Save, apply, and OK. This is pulse generator. Pulse generator setting is as your desired. If you can take 90 degree or 80 degree or 70 degree. That means the 70% time is on. If you are putting the 50%, That is the 50% of total time का 50% time is for the pulse with on and 50% is off. 90% means 90% off, only 10% time is off. Okay. Next, this is MOSFET switch. Okay. That is always, this is default value. FET resistance, internal inductance, this is default. Don't need to change anything. Snapper circuit are, again, this is diode. Okay. Inductor L, load. Okay. Time period is 1. Okay, run. Okay. This is your output. The first step is, this is output input voltage. Input voltage is 50 volt and you are getting the output voltage. Zoom करते हैं पहले. First step is zoom. Okay. First is input voltage is 50 volt and you are getting the output voltage. Output voltage when pulse, this is last is the pulse output. When the pulse is on, that is you are getting the 45. And again, when this pulse is off, only 10% and duration time is pulse is off. And that time you are getting the this output voltage. And when pulse is off, you are getting the output voltage is यहाँ पे 0. And again you are getting the output voltage as a pulse, and this is filter output voltage. Filter output voltage is near about to 40 5 are 47 volts at the 90% of duty cycles. 90%. दिखाई दे रहा है या अलग अलग इसको करें, वन खाली टैप करें एक साथ? एक मिनट, यहाँ पे मैं एक, if the duty cycle is taken as a 70%. 70% is taken duty cycle zoom and output voltage is near about to 35 volt. This is your pulse. This is, देखिए top portion is input voltage. This top portion is input voltage 50 volt, always fixed. This is output voltage जो आप बुक में पढ़ते हैं, output voltage. This is filtered output voltage. Filter means pure DC. This is pulsating as a pulse due to the pulse generator की वजह से क्या होता है, आउटपुट वोल्टेज एज ए पल्स जो आप में बुक में बनाते हैं आप. एंड you are finally getting the DC output after the filter 35 volt, and this is pulse generator pulse. देखिए दोनों मैच करिए आप, पल्स जनरेटर और ये. अदरवाइज सिंगल विंडो में हम आपको दिखाते हैं. दिस इज योर आउटपुट वोल्टेज. ये देखिए, ये आउटपुट वोल्टेज. आउटपुट वोल्टेज आपकी इस तरह से नजर आता है जो आप बुक में पढ़ते हैं. आई होप सिंगल विंडो में ज्यादा बेटर है. एंड at the different duty cycles, this time I will take only output voltage and input. Next duty cycle is take 50%. 50% means T on and T off both are equal time duration for T on and T off cycle. Means T on time is 50%, T off time is also 50%. So input voltage is 50 volt similar. Okay, that is the symmetrical. 50% time is on and 50% time is off. देखिए, for the pulse symmetrical, this is off time, this is on time, both are symmetrical, 50% on and off. So you can different duty cycle measure the output voltage. आउटपुट वोल्टेज आपको मेजरमेंट करना है तो यहाँ पे डिस्प्ले भी लगा सकते हैं. देन दिस वेवफॉर्म इज आल्सो कैन सेव. and this waveform is also you can save. इसको सेव करने के लिए कंट्रोल प्रिंट स्क्रीन and paste in paint, invert the color. Okay. Control print screen. Invert this color and this is your waveform. First is input voltage, second is output voltage without filter. This is output voltage with filter, and last is the pulse generator, pulse width. So this is step down chopper. Okay, this waveform is complete. Okay, start next step up chopper. Okay, this file is save, close. फिर से again start from first step. Okay. Step up chopper, again file new, model, again name, step up chopper. Step up chopper. Okay. Again start from first point. First click to the library browser. Okay. And click to the SIM cap. SIM cap, again click to the SIM power system. Next click to the power electronics. Then we have required the MOSFET. Add to the step up chopper. Right click, and again diode also required. Next is measurement. Measurement portion, measurement of output voltage and element. Element takes series RLC branch and electrical source, the DC voltage source, and again click to the SIM power system for GUI block. Next pulse generator and sync. Sync में आपको scope, again add the all components. Okay. step up chopper, first is DC source, okay, and again the inductor is connected in series with DC source. This inductor, so RLC replaced by L, and it is connected in series, and this MOSFET switch कंट्रोल आर। सर्किट डायग्राम आपको जैसे बना हुआ वैसे ही बनाना है, यहाँ पे सिमिलर, दोनों एक ही, जैसे आपने बुक में सर्किट डायग्राम है वैसे ही यहाँ पे भी डिजाइन करना है। बस वहाँ पे पल्स जनरेटर वगैरह नहीं लगा रहता है, यहाँ पे पल्स जनरेटर उसको पल्स वगैरह देना है, अदरवाइज तो वही सेम सर्किट डायग्राम। डीसी इंडक्टर हो गया, एंड मॉसफेट एंड डायोड, and load for rotation, control R for rotate. इनपुट वोल्टेज, वोल्टमीटर से क्रॉस द इनपुट। देखिए वोल्टमीटर आप हरदम पैरेलल में कनेक्ट करेंगे, एंड एमीटर इज ऑलवेज कनेक्टेड इन सीरीज। आप करंट भी मेजरमेंट कर सकते हो, आउटपुट करंट, इनपुट वोल्टेज, इनपुट करंट। R 200 ohm load, and again pulse generator. This is pulse generator. Pulse is given to the MOSFET gate signal. This is a scope, and always unchecked for data limit. Number of axis is input and output voltage. Get pulse. First point is, this point is connected to the input voltage. Second point is connected to the output voltage. And last point is connected to the gate pulse generator. Okay. And setting the value, input voltage default 100 volt, okay, take 100 volt, no problem. Next is this inductor 1 millihenry, okay. Next, pulse generators. Pulse generators magnitude you can choose 1 volt, 2 volt, 5 volt, maximum is 10 volt. If you are putting by default is 1, you take 5, no problem. You can take 6, 7, 8, 9, 10, or 1, any value. And next is periods, time. So time is, for the MOSFET switching frequency is kilohertz. So you can take 100 kilohertz or 1000 kilohertz. If you are taking the 1000 kilohertz, means 1 megahertz or 100 kilohertz. Okay, no problem. 1 e की power minus 5. E 1 e की power minus 5 means 1 into 10 की power minus 5 seconds means 100 kilohertz. Pulse width percentage per period. Pulse width means this is if you are putting the 90%. It means this is turn on for 90 times. 90% times is on, pulse is given. Only 10% time is pulse off. And phase delay is 0 in case of DC. Okay. Next, for the load, you are taking 200. Next, save and complete the task. Run. Simulation is always 70% most completed.
Swayam, sir. Yes. So, sir, and a large number of students. Some
देखिए, you are putting the pulse width ratio is 90%, means pulse is on time duration, this is on time duration is 90%, only off time duration, this is off time duration is only 10%. Total time period का 10% time is off, 90% time is on. And step up chopper, the output voltage from 0 to near about to 1000 volt तक जा रहा है, 1000 volt. And previous case 1000 volt, and again for this off when gate pulse is given for the step up chopper, means it is off, output voltage across the load is 0. And again when pulse is off, then you are getting the output voltage Vs plus Bl, and it goes from 0 to 1000 volt. एंड प्रीवियस केस देखिए, प्रीवियस केस में आपको दिखाता हूं यहाँ पे, देखिए इन प्रीवियस केस इनपुट वोल्टेज इज 50 वोल्ट, देखिए इनपुट वोल्टेज 50 एंड आउटपुट वोल्टेज फ्रॉम 0 टू 45 और 50 वोल्ट, यहाँ से उससे नीचे है 50 वोल्ट से, मीन्स आउटपुट वोल्टेज इज लेस देन द इनपुट वोल्टेज. In this case, step up chopper, input voltage is 100 volt and output from 0 to 1000. This is, and 90% time is on. If you are putting 50%, duty cycle is 50%. 50% pulse width 50%. Okay, and pulse width is 50%, and again run 50% means 50 time duration, means T on and T off both are equal. In case of step up chopper, the relationship output and input is, output voltage is Vs upon 1 minus alpha. Alpha is duty ratio. And step down chopper, relationship output voltage and input voltage is, output voltage V naught is equal to alpha Bs. Alpha is duty ratio. T on time upon total time periods. देखिए, the first is input voltage 100 volt, output voltage from 0 to 250, and this is pulse width. Pulse width is 50%. देखिए, on time and off time both are equal. On and off time, it depends upon the duty cycle. This waveform also you can save, edit, copy, and Okay, you are okay. Pulse shift is taken as a 50%. Okay, and again run.
Be of 1 month also, but in that case,
Okay, if you are putting the duty cycle is 50%. This is control print scheme. Control B, invert the color, and okay. This is step up chopper. स्टेप अप चॉपर में एक तरीके से और दूसरा सेकंड बेस को आप डिजाइन कर सकते हैं. सिंपली दिस पल्स जनरेटर रिप्लेस विद इन 10 मिनट्स कंक्लूड एंड सिंपली रिप्लेस बाय पल्स जनरेटर. देखिए अगेन क्लिक द लाइब्रेरी ब्राउजर्स, क्लिक टू द सिम कैप एंड पावर इलेक्ट्रॉनिक्स, and again coming to the control and measurement section. This is pulse signals. This time we are taking the PWM generator, same waveforms. देखिए आप तो पल्स जनरेटर लगाइए या PWM जनरेटर यहाँ पे लगा दीजिए. PWM जनरेटर, दिस इज टू पोर्शन. फर्स्ट इज P इज द फॉर द पल्स, ये कनेक्ट हो गया, एंड D इज डायरेक्ट ड्यूटी रेशियो. देखिए इसमें दिस सेक्शन इज ऑलवेज स्विचिंग फ्रीक्वेंसी. यू आर टेकिंग द 100 किलोहर्ट्ज. 100 kilohertz 1 3 4 5 and sample time is putting 0 for continuous functions. Apply and D is the duty ratio. The duty ratio, take the constant block. This constant if you are putting the duty cycle ड्यूटी साइकिल इज 0.8 या 0.7, 0.7 and 0.7 and directly connected to this. Otherwise, you can apply the PWM DC to DC generators. Otherwise, pulse generator. Pulse generator में आपने जैसे पहले पुट किया था, उसमें क्या था आपका मैग्नीट्यूड, टाइम पीरियड्स एंड पल्स विथ परसेंटेज. यहाँ पे डायरेक्ट ड्यूटी साइकिल दे दिया गया है, ड्यूटी साइकिल डी. तो डी की आपको डायरेक्ट यहाँ पे पॉइंट रखना है, कितने आप रखना है 0.7, 0.6, 0.5. ड्यूटी रेशियो इज ऑलवेज लेस देन 1 एंड अगेन रन. तो आप चाहे इस तरीके से यूज करें, चाहे आपको पहले जो बताया वो मेथड यूज कर सकते हैं एज पर योर डिजायर्ड. पल्स जनरेटर यूज करिए, आरपीडब्ल्यूएम जनरेटर एंड विद द हेल्प ऑफ ड्यूटी रेशियो 0.7, 0.6, 0.5 एज पर योर डिजायर्ड. चलिए क्वेश्चन और सेशन ले लेते हैं. किसी कुछ डाउट? नेक्स्ट टाइम पे इन्वर्टर बताएंगे. नेक्स्ट सैटरडे आई विल डिस्कस सिंगल फेज एंड 3 फेज इन्वर्टर्स.
हाँ जी स्टूडेंट्स, किसी को कोई डाउट नहीं है? जिनके पास मैटलैब है दे कैन ट्राई दिस. जिनके पास मैटलैब नहीं है वो इन वीडियोस को देखकर जस्ट ट्राई टू अंडरस्टैंड एंड स्टडी द सर्किट फ्रॉम द बुक आल्सो.
और फाइल भी इनको भेज देंगे मैडम. इनको जो भी है जिनके पास है वो अपना करके देख सकते हैं.
हाँ, ये वीडियो आपके साथ शेयर कर देंगे. आप जस्ट गो थ्रू द वीडियो अगेन, see all the steps and significance of all the components we have used. Okay, so during this time this is the only resource that you can access to understand the experiments. ठीक है, किसी को कुछ नहीं पूछना है? So next time सर ने जैसे बोला we'll do inverter. थोड़ा सा इन्वर्टर आप पढ़कर आओगे पहले से, the basic concept of inverter, not the circuit diagram but basics of inverter. ठीक है सर, विल कंक्लूड हियर.
ओके मैम.
ओके, थैंक यू सर.
थैंक यू.
है ना, अटेंडेंस आई गेस एवरीबॉडी हैज मार्क्ड. ठीक है, तो नाउ इट्स 11:25. यू ऑल विल गेट अ ब्रेक ऑफ 20 minutes and then we'll join the session of that guest lecture of SOC verification. ठीक है, so all be available there. Thank you. सर आप रिकॉर्डिंग बंद कर लीजिए अब.